about gas laws on physics. So first is we'll discuss about Boyle's law. So for tonight's presentation, we'll talk about Boyle's law. Question, Ethan? Okay. Okay, so Boyle's law, named for Robert Boyle. This law relates the pressure, volume, and temperature of a gas. So this means this is a variation on pressure versus volume, where temperature is constant. Karayahan na. Okay. So this law states that at constant temperature, the pressure of a gas varies inversely with its volume. So this relation is expressed as PV equals K, where K is constant. So this presentation shows a piston in a cylinder. So for example, this one, as the volume increases, where the piston is going up the cylinder, so the pressure decreases. Question, Ethan? Okay. And then another scenario is that when the volume decreases, the pressure increases. So this can be plotted on a pressure volume diagram as represented by this curve. So when the pressure is increasing, the volume decreases, and then vice versa. If the volume is decreases, so the pressure increases. Okay. So now we'll proceed to the problem solving using Mathcad. So I will show you guys on how to calculate using Mathcad. Okay, this is a modern way on doing calculation. So wait. I'll transfer now to Mathcad. Wait a minute. Okay. So we have here some physics problem. So we'll start. So this is the interface of Mathcad. So by using Mathcad, you're not going to use a calculator. It will automatically display the answers and the units of a certain parameters. So for example, we have this problem. Problem number 1. Okay. So I'll type here. A gas occupies 12.3 liters. So 12.3 liters is the volume at a pressure of 40.0 mm Hg, or millimeter of mercury. So this is unit of pressure. Okay. So question is, what is the volume? What is the volume when the pressure is increased to 60.0 millimeter of mercury. Okay. So in Mathcad, you'll establish what is given in the problem. So here we'll type here, let's say given. Okay. So we'll put here pressure 1, or let's say P sub 1. In Mathcad, you will automatically put this subscript 1 here. Then input the value as 40 millimeter of mercury. So here in Mathcad, we can select the units here. For pressure, we have here, pressure. Okay. Inches of mercury only. So we'll change this to, okay, this one. So we'll change this to millimeter. I think it's not recognized. So we'll change this to PSI, or pounds per square inch. PSI. This is also unit of pressure. Then we'll change this to PSI, just for representation. Okay, let's say the initial pressure is 40 psi, and then the volume V1 subscript 1 is equals to 12.3 liters. Okay. So these are the given variables. So the question is, what is the final volume, or V2? So this is question mark. So now the relation is that I'll put here the relation. So P1 V1 equals P2 V2. So this is the relation, because the law states that if the pressure is increasing, the volume decreases, and if the volume increasing, the pressure decreases. So now we'll substitute the value. So the unknown is volume 2. So let's see. Volume 2 is equals to P1 V1. Then in Mathcad, you can easily apply this equation over P2. And then you will notice that if I enter equals, it will automatically I'll change this first to PSI. I'm sorry. PSI, and then pressure 2 is 60 PSI. Okay. So here like that. So you notice that it automatically give you the value. So this is how easy to use the Mathcad. Okay? So here you can see that the value is 8.2 liters. So if you want to check the volume in, let's say, cubic meter, you can just type here like this, cubic meter, and then it will automatically give the answer, which is equivalent to 8.2 liters. Okay? So this is the final answer. So we'll go to problem number 2. Okay. Problem number 2. Wait. Tan, question?
No.
No question? Do you understand? Okay. Okay, problem number 2. If a gas at 25 degrees Celsius temperature okay, 25 degrees Celsius occupies 3.6 liters. I'll expand this. 3.6 liters at a pressure of 1 atmosphere. Okay. So what will be its volume at a pressure of 2.5 atmosphere? So the question here is final volume. Okay, same as this. So it's also asking for the final volume. Okay. So the law states that at constant temperature, that means there's no change in temperature. So this given at that condition, which is 35 degrees Celsius. So what is given the problem is V1 or volume 1 equals 3.6 liters. Okay. And pressure 1 or P1, this is how easy to use Mathcad to solve your problems in physics or other field of like mathematics. So P1 is 1 atmosphere. So the units of pressure is atmosphere. Okay. So P2 subscript 2 is equals to 2.5 atmosphere. Okay, so same relation as the law stated. So this is the relation. So we'll now calculate the volume of V2, the final volume. So V2 is equals to P1 V1 over P2. Then after that, you'll just press answer and it will automatically give you the answer like this. Ching. So instantly, you don't need to use calculator. You'll just, it will automatically compute the answer, which is 1.44 liters. And then, if you're using this for presentation purposes, you can highlight like math formatting the final answer like this. So like that. Okay. So any question, Tan?
No.
questions from our viewers. So, shout out to our viewers watching right now. Okay, we'll proceed. Viewers, if you have question, you can message directly in the chat. We can address your question if you have questions or clarification. Okay, we'll proceed with the next problem. This is problem number 3. The questions are all about Boyle's law first. We'll tackle other topics like Charles' law, Gay-Lussac's law in the next live. For this one, we'll just focus on Boyle's law. Tan, question?
No.
Okay. So, problem number 3. So, you can see it, how easy to calculate using Mathcad. So, you will love physics and mathematics as well. Okay, problem number 3. To what pressure must a gas be compressed in order to get into a 3 cubic foot with volume. Okay. Cubic foot. I'm gonna type like this. Cubic foot tank. The entire weight of a gas that occupies 400 cubic feet at standard pressure. Okay. So the given here is the initial volume. Let's see. So what is asked in the problem is the final pressure. So to what pressure must the gas be compressed in order to get a 3 cubic tank volume. Okay, so the given in the problem is V1 equals 3 cubic foot. So here you can easily select what is the volume. Okay, 3 cubic foot. So just type here like this. Okay, 3 cubic foot. And then when you see standard pressure, so the condition is the pressure 1 is atmospheric. So that is 1 atmosphere. Because the problem states that standard pressure. So that is 1 atmosphere. So P1 equals to 1 atmosphere. So this is the standard pressure. Sorry. The initial volume is 400. Okay. At standard pressure. So this is the volume, 400 cubic feet at standard pressure, which is 1 atmosphere, or the equivalent of 1 atmosphere is equals to 101.325 pascals. Let's say 1 atmosphere. You can easily convert the units. So let's say like this. So see, you'll just change this to math formatting and it will give you in decimal. So 101.325 Pascal or 101.325 kilo Pascal. Okay? So that is easy, very easy in converting units. Alright. So this is the standard condition. When the problem states that standard condition, that means the pressure is 1 atmosphere or 101.325 kilopascal in metric units. Okay. So now the problem asking to what pressure it's required in order to have V2 final volume. Wait. This is 3 cubic foot. So the problem is asking what is the pressure, to what pressure. Okay, so is equals to 400 times 1 atmosphere divide of 3 cubic feet equals. So the answer is, we'll change this to decimal format. So the answer is it gives Pascal, right? So we'll change this to atmosphere. You'll just type there and the value will automatically change. So the answer is 133.333 atmosphere. So this is the pressure value when the volume is compressed to 3 cubic foot. Okay? Because as the law states, if the volume is decreasing, the volume and the pressure increases. Okay? Tan, question?
No.
I'll give you an exam after this. Okay? So, this is very easy. Okay? With the use of Mathcad. Now, we'll proceed with the next question. Our next problem. Guys, continue to follow so that you will be notified once I have my live stream. I will also cover other areas in mathematics, so I will also show a calculation on that. So here, problem number 4. Mathematics box. Okay. So we'll type here the problem. So a gas occupies 1.56 liters at 1.0 atmosphere. So what will be the volume of this gas if the pressure becomes 3 atmosphere. So you'll notice that the pressure increased. So we'll expect that the volume decreased. Okay, so we'll expect the final volume is smaller than the initial volume. Okay, so we'll type here V1 equals 1.56 liters. Okay, and the pressure at that volume is P1 equals to 1 atmosphere. So the question is, what will be the volume? So V2 is equals to P1 divide the pressure 2 equals. So you notice that the volume decreased because the pressure increased. Okay, sorry. I'll put here P2. Put here, which is 3 atmosphere. Ito. Okay. Yeah, 0.52 liters. Okay, so the volume decreased. So the answer is 0.52 liters. So here, I'll use this. Okay. So in Mathcad, all the variables which is placed before the formula will recognize that the value of that variable. So like this. So this is how easy to use Mathcad. Ethan, question?
No.
Okay. So we'll proceed with the next problem. Problem number 5. Very easy, Ethan. Okay? With the use of Mathcad, right? Okay. So we'll type here problem number 5. So I'll put a representation for you to visualize. Okay. I'll put it here. You can just snip the image and then add this to your presentation so that you can easily visualize the problem, what is asked or given in the problem. So here, and then I'll type problem number 5. Okay, so a gas occupies 11.2 liters at 0.86 atmosphere. What is the pressure? What is the pressure if the volume becomes 15 liters? So you notice that the volume increased. So you'll expect that the pressure will decrease, because the law states that if the volume increases, the pressure decreases. And if the volume decreases, the pressure increases. So this is the Boyle's law. In Boyle's law, the gas behaves in this condition. Okay. So what is asked in the problem is the pressure. Okay. So given V1 or volume 1 equals to 11.2 liters, and pressure in that volume is 0.86 atmosphere. 0.86 atmosphere. So we'll place it here so that it will be clear. Okay. So based in this relation, in this law, so what is asked in the problem is the pressure. So P2 is equals to P1. So make sure that when you write the equation, you will write exactly what is you write in the variable section. So because in the formula, it will check on the variables or parameters that you placed before the equation. So P1, B1 divide V2. So equals, then automatically it will give you the answer, which is in Pascal, but we can easily change that to atmosphere by putting or typing here atmosphere, and then the value will automatically change after you change the unit. See, it is 18.523 atmosphere. So you can see that the pressure increase because the volume I forgot to type the final volume. Wait. V2 here, formatting. V2 here is 15 liters. Okay, so it will give you 642 atmosphere. So the pressure increased because the volume increased as the low stage. Okay, so Ethan, question.
No.
Okay, we'll proceed with the next problem. Problem number 6. There's a lot of problems we can easily compute without using calculator and just by using Mathcad. Okay, 500 milliliters of a gas is collected at 745.0 Pascal. Pascal. What will be the volume at standard pressure? Okay. So the problem is ask what is the volume at standard pressure, because in initial condition the volume is 500 milliliters at 745 Pascal. Okay. So standard pressure is 1 atmosphere or 101.325 kilopascal. Okay. So V1 is 500 milliliters, and the pressure is, we'll put it here, the pressure is 745 Pascal. Pascal. Okay. And that condition, standard pressure, the value of pressure is is 101.325 kilopascal or 101,325 Pascal. Okay. P2. Okay. P2 is equals to 101,325 Pascal. Because this is a standard pressure or atmospheric pressure. Okay? So, the volume in that atmospheric pressure or standard pressure is P1 times B1 divide P2 equals 0.0004 liters. So we'll change this to milliliters. We'll just type the unit here and it will automatically change to 3.676 milliliters. Okay? So we still have 4 problems to solve for tonight. Okay. So I'll just copy this to okay. Wait. Okay, it's okay. Okay. So problem number 7. Convert 350 milliliters at 740 inch of mercury. To its new volume at standard pressure. That's standard pressure. Okay. So at standard pressure, 1 atmosphere is equals to 101,325 Pascal, but we'll change the unit to inches of mercury. So we'll change here from the units. So pressure this one. So the value is at standard condition, that is 29.9 inches of mercury. That is standard condition, or 101,325 Pascal or 101.325 kilopascal. So this is the standard condition, atmospheric. Okay? So what is given in the problem is V1 equals 350 milliliters, and the pressure in that volume is 740 inch of mercury. So this is actually, this is the P2. It is the which is the standard condition. So I'll remove this atmosphere here. 29.921 29.921 inch of mercury. So this is the standard condition. So I think we'll add a note here. This is the pressure at standard condition. Standard condition, or we can see atmospheric. This is the value. Okay, so now we'll calculate the volume. So the value will become the volume at standard condition. So P1 times B1 divide P2 equals. So it will give you 8.656 liters. So we'll change this to milliliters. So it will become, we'll change this to decimal form. It will give you 8,656.128 milliliters. Okay? Then, problem number 8. Question, Ethan, Dave, AJ, no questions? We'll proceed. You have exam after this. Okay. Problem. Actually, you can adjust the decimal places. For example, this one. We'll change to 1 decimal place. Like that. Okay. Or you can also select 2 decimal places. It will automatically round off. So problem number 7. Number 8. Okay, sorry. Problem number 8. Convert 338 liters at 63 atmosphere. This is the unit of pressure. To each new volume at standard pressure. So again, standard pressure is atmospheric condition. Okay, so what is given is V1 equals to 338 liters and pressure is 63 atmosphere, and the standard condition, standard pressure at standard condition is P2 is 1 atmosphere. So again, this is the pressure at standard condition or atmospheric, let's say atmospheric pressure. Okay, so volume 2 is being asked in the problem. This is the volume at standard condition. Okay, so P1 B1 divide P2. The answer is, it should be in liters. Okay, So we'll change this to decimal. So the answer is 21,294 liters. Okay. And then problem number 9. Okay. So again, for Boyle's law, if the volume, let's see here, if the volume increases, the pressure decreases. And if the volume decreases, the pressure increases, which is the relation between the pressure and the volume at constant temperature. That is the law stated. Okay? So problem number 9. Number 9. Convert 273.15 milliliters at 166 kilopascal to each new volume. Wait, we'll put it in the next page. To each new volume at standard pressure. Okay. So, volume B1, initial volume is 273.15 milliliters, and the pressure is 166 kilopascal. So, and then the pressure at standard condition is P2 is 101.325 kilopascal. Again, this is the pressure. This is the pressure at standard condition, or shall we say atmospheric pressure. So now we'll calculate the volume at standard condition. So B1 divide P2. So you can see that in the problem the pressure decreased. So we'll expect that the volume is increased. Will increase. Okay. So now we'll calculate. So we'll change this to milliliter. So now we'll have a value of 447.5 milliliter, which is greater than 273, or the initial volume. Okay? So now we'll calculate the last problem. Problem number 10. So this is how easy to calculate problems using Mathcad. Very easy. Right, Ethan? Do you agree? Okay, problem number 10. Convert 77.0 liters at 18 inch of mercury to each new volume at standard pressure. So the problem is asking the volume at standard pressure. Okay. So we'll expect that since the the standard condition, the pressure is higher than the initial pressure. So we'll expect that the volume will decrease. Okay. So B1. So this is how easy to solve gas flow problem in physics. 7 liters. And the pressure is P1, 18" of mercury. So again, at standard condition, the value of pressure is 29.9, let's say here, wait, 1 atmosphere is equals to inch of mercury. So you can easily compute the value, or you can easily convert the units. Okay, so the pressure is 29.921 inch of mercury. So again, this is the pressure at standard condition or atmospheric pressure. So volume at that condition, V2, is equals to P1 B1 divide the standard pressure, which is P2, is equals 46.322 liters of volume. So see, the pressure decreased since the volume decreased since the pressure increased, as the law stated. So that's it for tonight live. So for the next session, we'll cover the next law, which is the Charles law. So we'll cover problems that relates to Charles law. Okay? Understand? Okay. So we'll review with that Boyle's law. So here, Boyle's law. So as the volume increases, the pressure decreases. So for example, this is a piston and a cylinder. So you notice that as the volume increases, the pressure decreases. And if the volume decreases, the pressure increases. And this is the pressure volume diagram. This is the pressure and this is the volume. So this is the curve represented by that relation. So this is at constant temperature. Okay? So thank you until the next session. Thank you for watching and good night. Alright? Bye-bye. Thank you. Bye-bye. Okay, thank you all. Thank you all for watching. Until next time. Okay, bye-bye. Night.